Okay, word problems today. Attention up here, please. Thank you. So we're going to do exponential, growth, and decay. So exponential growth occurs when a quantity exponentially increases over time. So our formula that we're going to use is y equals a times 1 plus r to the exponent t. So our a is the initial amount. Starting amount, the r is the rate of growth. And your t is time. So a lot of students ask, where does that 1 come from in there? So if we were finding how much something grows, we would take whatever that decimal percentage is and multiply it by the number. And that would tell us how much it is getting, how much, the amount of how much it's bigger it's getting. But we have to add the original amount back to that to actually get the new amount. So that's where that 1 comes from. It's the original amount plus the increase there. So first example, the original value of an investment is $8,100. If the value has increased by 7% each year, write an exponential function to model the situation, then find the value of the investment after 15 years. So growth or decay? There's a word in here that tells us which one it is. What word? What is it? Growth or decay? Growth. What's the word? Increase. So this is our key word here that tells us it's growth. Okay, so it's a growth one. We'll talk about the multiplier in a moment. So we're going to use our formula, a times 1 plus r to the t. So what is our starting amount, our initial amount on this one? 1,800. And what is our rate of growth? 7%, which is what is a decimal? 0.07. So you're always moving it 2 decimal places to the left there. It's always 2 decimal places because it's per 100. That's what percent means. What's our t in this one? What's our time? 15. So we want to solve for y. So how would we do this? Could we just put this in our calculator? Yeah, so just put it in our calculator. What do we get for an answer? So this is money. So how should we round? 100. That's right, to the nearest cent, which is hundreds. So $4,966.26. So our multiplier, what is it that we're multiplying it by itself every time in this problem? And so what to the 15th? So what would this be if we added those 2 numbers there? What's 1 plus 1.07? So you're multiplying that by itself 15 times. So that's your how it's exponentially increasing over time. Okay, so on your paper, you don't have these two questions, but on your homework assignment, you are going to have to answer those questions. So I'm answering them on these two here. On this one, and I'll answer it on another one. Okay, if I move on to the next slide. Okay, problem number 2. Gavin's Nana loves him very much. His Nana put $2,000 in a savings account that earned 6% per year. Nana is a good investor. She told Gavin that he can't take out the money until it reaches $3,600. How long until Gavin can spend that sweet Nana cash? So growth or decay? Growth. A lot of times there's a word in this one. It's, I guess the earns. So then we have a y equals a times 1 plus r to the t. And what's our initial amount on this one? 2,000 is where we start. What is our rate of growth? R. .06. And do we know the t on this one? No, that's what we want to find. And so this 3,600 goes on the y, it's our ending amount. So this is our starting amount here, and this is our ending amount here. So how would we solve that? What would we do first to solve that? We've got a variable t that we want to solve for. So we've got to eventually get that by itself. But before we do that, what do we need to do? Divide by the 2,000 on both sides. So because we've got to get this part alone. So we're going to first divide by 2,000. Does that make sense? So this can be simplified. I'm just simplifying it by taking off the 2 zeros off of each one. It can be simplified more if you want. And then 1 plus 0.06 is 1.06 to the t. Now we got to solve for that t. How do we get to that exponent t? Already in exponential form. Okay, it's been a hard question all day. It always is every year when we do this. Yes, we need to take the log of both sides. Log of 36 over 20 equals the log of 1.06 to the t. And we did that because now we can move that exponent. Where can we move the exponent? To the front. And we can't do that unless we use a log. So that's why we use the log here. So now what's my next step? My log of, yep. So you're just going to do that in on your calculator. And we're going to round it to the nearest tenth on this one, but you could round to the nearest hundredth if you wanted. What do we get for this one? You want to be doing this on your calculator because you want to make sure that you're able to get it yourself. 10.1, and it would be 10.1 what? Years. So per year there, so that's where the years comes from. That makes sense? Okay. Okay, next example. You guys still looking at this? Okay, exponential decay. Formula is very similar. And since it's decay, it's going to be a minus. That's right. So it's the same formula, except it's a 1 minus r to the t. So our A is the initial or starting amount. The R is our rate of decay. We call it a decay. And then our T, again, is our time. So this problem here, an investment of 12,000 is losing value at a rate of 4% each year. Write an exponential function to model the situation. Then find the value of the investment after 9 years. Growth or decay? Decay, what's the word here? Losing. So we have y equals a times 1 minus r to the t. It's going to happen as you will have to think about that as to whether it's a plus or a minus. We decided it was the decay because of the losing, and that's why it's a minus there. Does that make sense? Okay, so what is our initial amount? 12,000. What is our rate of decay? 0.04. And what is our time t? 9. And so how would we find that? Just put it in your calculator. Yep. Okay. Money. What you get, Sally? And 40, and so is it 40 or 41? Yeah, easy to do, yeah. So $8,310.41. So what would be our multiplier on this one? So Shireen just said 0.96. Where did you get the 0.96 from? Yep, so she took the 1 minus 0.04 on her calculator, and she got 0.96. Does that make sense? That's your multiplying by itself 9 times. That's your multiplier. So the multiplier is what you're multiplying by itself number of times. Yeah, so it's what's in that parentheses for these problems. That's simplifying it. Okay, last one. Olivia got a Gucci bag for an early graduation present. It was worth $12,500 when she got it, but she's been using it pretty hard, so it's depreciated in value at 6% a year. She decides she's going to sell it when it is still worth $8,000. How long can she keep using her lovely bag? So growth or decay? It's decay. What's the word? Yep. Yep, that's the word. Yep. D something. And so our formula is A times 1 minus R to the T. So what's our initial amount? 12,500, and she got it. What's the rate? 6%. So that would be, what is a decimal? 0.06. Do we know the time in this one? No, that's what we want to find. And so our ending amount on this one is 8,000. Okay, so how do we solve that? What's our first step? What's that? Divide by that. That's right, by 8,000. Good. Not 8,000, sorry, 12,500. So that could be that 80 over 125 can be simplified more. If you want to, you can. I'm just taking off those zeros so I don't have to write as much. So now what do I do? It's not 1.06. It is 0.94. Thank you, Nicole. 0.94. And then what do we do to both sides? Log to get to that exponent. So the log of 80 over 125, the log of 0.94 to the t. And then what do we do next? So move the t to the front. So it's t times log 0.94. And then yep. And we get about 7.2 years. Okay, this doesn't have anything to do with this problem, but there are problems on the worksheet where we have to change decimal percent to a decimal. What would this be as a decimal? 1.5% is. So do we still move 2 places? So 0.015. So 2 places always, 1, 2, because it's per 100.